everyone, welcome back to this data science series. In this lecture, we are going to cover dimension reduction in data science. So, let's know what is dimension reduction. Dimension reduction is like having too many dimensions, like too many predictors in our data set can lead to overfitting, multicollinearity, um, and also double counting, curse of dimensionality, and it also violates the parsimony. But these are the several terms which I have explained. But what exactly are these terms? First, we can go with multicollinearity. What is multicollinearity in Python? Like, what is multicollinearity? Multicollinearity arises when two or more independent variables in regression model are highly correlated. Like when they are correlated much, then they can create much instability. Also, it can lead to unreliable coefficients. And it is very important to detect these multicollinearity predictors and to remove them and to remove them so that our data model can become much more reliable. And in dimensionality, the idea is to remove the predictors and keep the least predictors as much as we are required, maintaining the stability of the data set. And also it also doesn't affect our data set, but provided we are keeping the predictors as low as possible. Let's see the next slide, which is how we can do this using principal components analysis. What is PCA? It is a powerful tool which is a linear transformation method that projects the data onto a lower dimension space while preserving as much as variance as possible. It's widely used for dimensionality reduction in data science. As I've said that we have so many predictors, so we are like shortening them or reducing them while preserving as much as variance we can preserve. And let's see the code for these two in Python. Okay, so multicollinearity exists occurs when two or more predictor variables in a model are highly correlated. This can distort the regression estimates and can make the model less reliable. And to detect it, we use a variance inflation factor VIF. And if the VIF value it is greater than 10, then it indicates high multicollinearity. So let us check whether we have multicollinearity or no. So here we have imported those packages required in our code, and we have data set. Then we'll add a constant. Then we have calculated variance inflation factor VIF for each of these data sets, which is feature and VIF. Then we are printing those VIF values. So let's check if these are greater than 10 or not. We will know that how much multicollinearity is in our code or in this data set, so that we can reduce the predictors, reduce the variance, and so that we can keep our intact our data set. Also, it doesn't affect our data set by overfitting or not overfitting, because we have so many predictor variables which can intervene much. Also, curves of dimensionality, because as the degree of dimensionality um, increases, there the space becomes sparse. So we have this VIF values. Now let's have a look on PCA, which is principal component analysis. Principal component analysis is a technique which we use to reduce the dimensionality of the data while retaining most of its variance. But this is what we do when we get the VIF values higher, like we have got the multicollinearity value greater than 10. So, which is high multicollinearity. So this we do this, we import the packages. Then we have this example of data set. We'll standardize the data, apply PCA, and then we'll create the data frame using this data frame function, and then we'll print the output. Let's have a look on our output. It is running. So this is what actually is multicollinearity and principal component analysis. But why do we need dimension reduction? Also, if we have so many predictor variables, it can also lead to double counting. Like double counting, we have so many predictor variables, and if they are correlated, we can double count them, can lead to redundancy, and so which can not make our data set reliable. And this is what we have PCA values. Now, let's understand the concept of dimension reduction. We can reduce the complexity and we can improve the performance. Like how we can reduce the complexity is that we can fix the data in a smaller set that captures most of the information. Like we want a smaller set which have most of it in it and not the unnecessary parts or which can lead to overfitting. This makes data analysis more efficient and insightful. Also, it helps in improving the performance. Now, what are the advantages of dimension reduction? It improves the model performance and reduce the complexity, as we just read, and it enhances the data visualization, better insight from complex data, and reduced storage requirements. Because yes, we are again like shortening or reducing the dimension, so storage is also less required. And then what are the limitations? Loss of some information, because in reducing the information we can also lose some of the important information. Then we can have difficulty in interpreting the new features, because as we are reducing the predictors we have to take new predictors, like common predictors. If we are removing, then we need to have a common predictor, a single predictor to predict those values. And then bias may be introduced, and also it is not very suitable to all the data types. It can also help in visualization, because in PCA you can see in these two images, like in before and after of PCA, it can be very difficult to visualize before PCA, but after PCA it is like quite helpful to visualize. We can have optimal number of principal components by scree plot and by using variance. And we can have principal components and loadings, which have principal components, as each principal component is a linear combination of original features with loadings representing the contribution of each feature to the component. And loadings are the interpreting, and loadings helps in understanding which features are most important in each principal component and how they relate to the original dataset. So this is what dimension reduction is: reducing the dimensions and the predictors and having those in a small space, and the space having a much data inside it without having much loss to the dataset. So this is what dimension reduction is. This is it for this lecture. Thank you for watching this video.